Okay, this is lesson 47, systems word problems. So we already know how to graph systems and we know how to solve them through elimination. We've been talking about this every day. Where's the answer? Where are the lines? Intersect, okay. And then yesterday we talked about how they don't intersect. Sometimes that's no solution, and then sometimes they intersect all the time because it's the same exact line on top of the other one. Okay? So today we're going to actually apply it to real life, okay? So this systems of equations, I'm going to say, like, if you go into business, I have a business degree, so when I went to university, I got my business degree. And we talked about this topic, what you're talking about in Algebra 1, like all through the 4 years I went there, okay? Because a lot of businesses, they look at their, demand and supply, and they look at how to maximize their profit. So if you go into business or economics, you're going to look at this, okay? Algebra 1 stuff, okay? Or we're going to look at in and out in a couple weeks. In and out, did you know that in and out, they use systems of equations?
Really?
Yep. Yeah, so we're going to be looking at how that applies. So, but today we're going to apply it to real life problems, so word problems, okay? So you already know how to deal with them, you know how to solve them. That's really good. So here we go. So the steps for today, when you look at word problems, you need to read the problem carefully, okay? Raise your hand if you look at word problems and you sometimes just skip over them. You're like, oh, it's a word problem, okay? Okay, it's good that you're honest. I was like that too, but the first few times you go through it, it's hard. Just reread it, try to understand what's going on. Then 2, the thing we have to do is define any variables with sentences. We're going to talk about that. 3, create a system of equations, and 4, solve the system. Number 4 is the easiest thing. Number 1 through 3 will be the hardest thing you're going to go through. So today, the big thing what we're doing is 1 through 3, okay? And then once you get to 4, you should be able to solve it on your own pretty quickly. Okay, so here we go. Number 1, you don't need to write this down, so just watch right now. You don't even have to write the problem down. We're going to write it down later, okay? Okay, suppose your high school sells a total of 292 tickets for a basketball game, okay? Right? Can y'all imagine there's a basketball game here and 292 people come to our gym and there's like people sitting in the front and they're like selling tickets? Can y'all imagine that right now?
There's 2 tonight.
Okay, good. So let's just say this was last week, okay? Looking up here, an adult ticket, let's say they're like, oh, adults get charged $3 and a student ticket costs $1, okay? So we can imagine that there's adults and students. And so the high school ends up collecting $470 in ticket sales after the game, right? And solve a system to find the number of each type of ticket sold. So these problems, you have to really read the problem and think about it, okay? Can you all imagine people sitting in the front of the gym and being like, oh, that's $3, that's $1. And then at the end of the night, they count up all the money. How much money should they have at the end of the night here?
$400.
Good. And then they like count all the tickets they sold, and they're like, we've sold how many tickets?
292.
292. Okay, so is it possible that 100 students could have come to our game?
Yeah.
Yeah. How many tickets would they, or how much money would they have made if they had 100 students come?
100.
100. Is it possible that 292 students could have come?
Yeah.
No, wait, no.
Why not? I thought there's 292 people that came.
Oh, tickets $1, and they made $478. If it was 292 people, then they would only have 292.
Ah, good. Did you all hear that? So that's why we have a system, because we know that it could have been possible that 292 kids came, but we know it's impossible now because how much money did they really make? $470 and not 292. Okay, so do we know that adults and kids came to our?
Yeah.
Yeah. Okay, good. So do we know how many adults and kids came? No, it could be 100 kids, it could be 50 kids, it could be like 1 kid. Okay, we don't know how many adults came. It could be 100 adults, it could be 5 adults. We don't know. Okay, so we have to figure this out. It's a variable, right? So the first thing you want to do after you read the problem, once you already know what you're imagining, you imagine the gym, people selling tickets, kids coming and adults coming to see the game. Then we have to define any variables with sentences, okay? So I'm going to make 2 variables, okay, because we already know how to make a system of equations. So what variables do you want to use for adults and students? Do we want to use x and y, or do we want to use different variables to represent adults and kids? Well, since adult starts with A, I'm going to use A as adults. So I'm going to make a sentence. I'm going to say let A equal to the number of adults. Okay, that's what I mean by define any variables. Okay, so if I used A for adults, what should I use for students?
S.
Okay, good. So do we always have to use X and Y? No. Okay, so A equals the number of adults, S equals the number of students. Okay, you follow me right now? Okay, so let's just imagine really quick. Let's say 10 adults come to the game, and they sold tickets for $3. How much money did they just make? How'd you figure that out?
3 times 10 is 30.
10 times 3, or 3 times 10, right? So what operation are we going to use to figure out how much adult multiplication? So we know that adult tickets, look up here, $3, and we're going to multiply that by A, right? Because 3 times A is how much money they make off adults. Okay, so how much are student tickets then? $1. So we're going to add that in there. We're going to say that we also are going to consider student tickets, and that they are $1, and we're going to multiply that by S, okay? We know that all of the adult tickets sold plus all of the student tickets sold equals how much money? How much money they make?
470.
470. Well, $1 times S. Yep. We always put the coefficient in the front of the variable. Okay? Follow me so far? Give me a thumbs up if you're following me. Thumbs down if you're not. Okay, good. Okay, so a system. How many equations do I need for a system, though? 1 or 2? This is one equation. How many equations do I need? 2. Okay, so we need to figure out a way to get another equation. What other information do we know about it? This is how much money they made, right? How do we figure out how many, or what else can we use to make another equation? What other information do they give us? Good. How many people came, everyone?
202.
Do we know how many adults came? No. Do we know how many students came? No, but do we know how many total people came?
Yes.
So, good. So, couldn't we say that the number of adults plus the number of students is 292? Would you agree with that? Good. Couldn't we solve this now? Didn't we do this for the last 4 days? Yeah, what variable would you eliminate? A's or S's? S is good. So I'm going to put parentheses around the S, or the second equation, and then what would I do? Add or subtract the second equation? Subtract, good. So I'm going to subtract. So we got 3A minus A is going to be 2A. The S's cancel out. They're eliminated. 470 minus 292 is 178. Divide both sides by 2. And I can't do this in my head. I can't do this in my head, so I'm going to do a side problem. So this is why we do all these side problems at homework. We have to do 178 divided by 2. You just work it out like this, okay? Don't do it in your head, because I'm noticing most students are not able to do it in their head, okay? So we know that there are how many adults at this game?
89.
How do we figure out how many students there are?
You plug it in.
Plug it in, okay? Which one would you use, equation 1 or equation 2?
Equation 2.
Good, why?
Smaller number.
Because it's smaller numbers, okay? So we're plugging it back into equation 2. Adults plus students, 89 plus students is equal to 292. You subtract, there are how many students?
203.
203. So then this is a word problem. Am I going to make an ordered pair?
No.
No. We're going to say that there's 89 adults and 203 students. Okay? Does that make sense? Okay, good. So, any questions on this one problem? Because this is the only problem I'm going to show you today. Right? Any questions on this one problem? Okay, so what I'd like you to do, let's have one still at 2's. I want you to explain, how did I set up the problem? How did I set up to here? How did I set up the equations, okay? Explain the whole thing. And then 2 Stella ones, when they're done, how did I solve it? How did I figure out how many students and adults there were? Okay? One's talk first, then 2's. Ready? Set, go.